Hello friends, I welcome you in lecture number 11 on double integrals. In this lecture we are going to discuss how to change the order of integration in given double integral and how to evaluate the double integral by changing the order of integration. Sometimes it is not possible to integrate given function in given order. That is, sometimes it may be possible to integrate with respect to y easily as compared to with respect to another variable, say x. So in those cases, if we know how to change the order of integration, then we can evaluate the given double integral easily after changing the order of integration. We understand with the help of this example. Here our integral is sin y over y. Limits are from y equal to x to y equal to pi. X is from 0 to pi, and function is sin y divided by y, and order of integration is first with respect to y and then with respect to x. So, and we are asked to find out value of this double integral by changing the order of integration. So here we can observe that if we integrate in given order, then we have to integrate this function with respect to y first. So we know it is not easy to evaluate this integral. We are not having any standard formula for the integral of sin y over y with respect to y. So if we have not given that evaluate this integral by changing the order of integration, then also we have to change the order of integration, because it is not easy to evaluate this integral with respect to y first. So we will change the order of integration. We will integrate with respect to x first and then with respect to y. For that we have to sketch the region of integration, and we have to find out the new limits of integration such that our order of integration becomes dx dy. So whenever we have this type of problem in which we want to evaluate our integral by changing the order of integration, we will first decide the limits of integration in given double integral. First we will write down given information, that what are the limits of integration in given integral, and from those limits we will be able to decide the curves required for sketching the region of integration. So here first we write down the limits of integration in given double integral. So in given double integral, order of integration is dy dx. So these are the limits for y and these are the limits for x. So y is from x equal to x to y equal to pi, and x is from 0 to x equal to pi. So from this we write that limits of integration in given integral are y is from x to pi, x is from 0 to pi. So we can see we have these different curves here. Y equal to x, line passing through origin. Y equal to pi is horizontal line. This is y axis and this is line parallel to y axis. So we can easily sketch these lines in the xy plane, and we are able to decide the region of integration in xy plane, and we can decide the intersecting points also. If we consider these two lines, then they will not intersect, they will intersect if we put x equal to pi here. These two lines will intersect at point pi comma pi. Similarly, if we consider these two, y equal to pi and x equal to 0, then they will intersect at this point 0 pi. Similarly, if we consider this x equal to pi and y equal to x, then if we put x equal to pi, we obtain y equal to pi. So these two will also intersect at this point pi comma pi. and x equal to pi and y equal to pi will also pass through the same point pi comma pi. So here we have simple curves, all the four curves are lines, so there is no problem in the sketch of region of integration. So first we consider the region of integration and then we decide how to change the order of integration. So this is y-axis, means x equal to 0, and the maximum distance on both the axes is required as pi. So suppose we assume that this much distance is pi, so that we can have approximately this point. Suppose this point is pi comma pi, and this we can consider as 0 pi. Now we sketch the different lines. We have y equal to x, y equal to pi, x equal to 0 and x equal to pi. So x equal to pi means passing through these 2 points. So we can sketch x equal to pi is the line parallel to y-axis and it is passing through these 2 points. So this is the line x equal to pi. Also we require the line y equal to pi. So it is the line passing through these 2 points. So we sketch the horizontal line passing through these 2 points. So this is the line y equal to pi, and we require the line y equal to x. So it is also passing through y equal to it is also passing through pi comma pi and origin. So we join these 2 points and we are able to approximately we are able to sketch the line y equal to x, as we know that it is the line passing through origin making 45-degree angle with positive x-axis. This is x-axis, which we can represent by y equal to 0. So now we have sketched these 4 lines: y equal to x, y equal to pi, x equal to 0 and x equal to pi. Now we check limits of integration are y is from y equal to x to y equal to pi. So this line is y equal to x and y equal to pi is this line. So y is in this direction, y is increasing from y equal to x to y equal to pi, and limits of x are from x equal to 0 to x equal to pi. So this is the boundary of x equal to 0 and this line is x equal to pi. So our region is this region, which we can show by these lines. This is the region of integration on which we have to evaluate our integral. So we can see here we have y equal to x. This is the boundary of y equal to x. So y is from x to y equal to pi, and x is from x equal to 0 to x equal to pi. So this is the region of integration. Now in given integral, order of integration is with respect to y first and then with respect to x. So if we consider this order of integration, then for this order we consider vertical line. If we want to integrate with respect to y first, as we know, we will consider vertical line, but here we are asked to change the order of integration. So to change the order of integration, we will consider horizontal line passing through the region of integration. Okay, so we can mention that in given, first we write down that in given double integral, order of integration is, in given integral, order of integration is first with respect to y and then with respect to x, and this order is obtained by imagining or by considering, this order is obtained by considering a vertical line passing through the region of integration. So this is given information. This is what we are given in the given double integral. Now we have to change the order of integration. So now to change the order of integration, we have to consider horizontal line. So first we have written what is given, and now we want to change the order of integration. So we know that given order is obtained by considering vertical line. So to change the order of integration, we will not consider vertical line now. We consider horizontal line passing through region of integration. So our limits will also change. So now we consider horizontal line passing through the region of integration, and we see what we obtain. So we can consider horizontal line in any part of the region. There is no problem here, because if we consider horizontal line in any part of region of integration, this is our region of integration, and we are considering horizontal line passing through the region. So there is no problem. If we consider horizontal line here, then it will enter on y-axis and it will leave on this line y equal to x. So if we consider horizontal line in any part of the region, it will enter on the same curve and it will leave on the same curve. Now on the horizontal line, y becomes constant and x is changing. So we will decide the value of x at these points. At this point line is entering in the region, and this point is on y-axis. So at this point value of x is 0. So here we write that line enters the region at x equal to 0. This point is on the line y equal to x. So here value of x is y. So we can write line leaves at x equal to y. Now to cover the remaining region, we will consider horizontal lines starting from this point, that is the lowermost point. So at this point value of x is 0, and we will be drawing horizontal lines up to this part of the region. So all these points are on the line y equal to pi, and at all these points value of y is pi. If we consider any point in this part, then all these points are on the line y equal to pi, so value of y is pi there. So all these are uppermost points of the region and value of y is pi. So at this point value of y is 0, at all these points value of y is pi. So limits of y will be from 0 to pi, and x will be from x equal to 0 to x equal to pi, and this is the region of integration. So now we write down the limits of integration, the new limits of integration. The new limits of integration r. So x is from 0 to x equal to y, and y is from 0 to y equal to pi. So let me check again. X is from 0 to x equal to pi, and here y is 0 at lowermost point, at uppermost point y is pi. So now we find out that we have obtained the double integral which is equivalent to given double integral. Given double integral is sin y over y. Integral has order of integration first with respect to y and then with respect to x, and limits are from x to pi and 0 to pi. X to pi and 0 to pi. And after changing the order of integration, and we know that if we change the order of integration, value of double integral never change. So now here limits are from x equal to 0 to x equal to y, and y is from 0 to pi. And by Fubini's theorem, value of both the integrals are same. We know that order of integration does not matter. If we integrate with respect to y first or with respect to x first, value of double integral remains as it is. But here we are asked to change the order of integration, so therefore we have written an equivalent double integral to given double integral, which is this one, in which order of integration is first with respect to x and then with respect to y, with limits of x from 0 to y and limits of y from 0 to pi. And now we evaluate this double integral. So for simplicity we are writing this in the bracket. It is not necessary that you should always write in the bracket, but just for conveniency we consider this as inner integral. Here integration is with respect to x, so we will consider y as constant. So because y is constant, sin y over y is constant, and integral of dx is x. So this is sin y over y, integral is x, and here limits of x are from x equal to 0 to x equal to pi, and after putting limits we will obtain function of y, which we will integrate from y equal to 0 to pi. Now first we put here x is from 0 to y, and y is from 0 to pi. So first if we put x equal to pi, y, that is upper limit, we have we can write one more step, sin y over y into y and minus x equal to 0, and then we integrate with respect to y from y equal to 0 to pi. So we can see this becomes easy now. Y will cancel out and we are left with integral of sin y with respect to y from y equal to 0 to pi, and this is easy to integrate. Integral of sin y is minus cos y, limits are from 0 to pi. So first we put y equal to pi minus y equal to 0, and as we know cos pi is minus 1, and this is going to be negative negative positive, and cos 0 is 1, so this is also 1 plus 1, so answer is 2. So we have obtained value of this double integral easily by changing the order of integration. We can observe that if we integrate this with respect to y first, then it is not possible to find out integral of sin y over y with respect to y easily. We don't have any standard integration formula for this type of integral. So what we have done is we have changed the order of integration, and we are able to find out value of double integral easily. So sometimes change of order of integration is required to find out value of given double integral. If given double integral is not easy to integrate in given order, then we can change the order of integration, and we might be integrate with respect to that changed order easily. So and if you are asked to find out value of double integral by changing the order of integration, then you must change the order of integration, even if it is easy to integrate with respect to given order. So sometimes they ask this type of questions, that evaluate the value of double integral by changing or by reversing the order of integration. So if it is written in your question that you have to evaluate double integral by reversing or by changing the order of integration, then you must change the order of integration, and then you have to integrate with respect to that new order of integration. So this is all about today's lecture. I hope you like this lecture. Thank you very much.